Hello, everyone, and welcome to How to Build a Llama 2 Fully Private GenAI App webinar. My name is Diogo Dantas, and I'll be your moderator today. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you are currently in a listen-only mode. You may submit questions throughout the session using the Q&A function in the lower section of your Zoom console. If this is your first time joining in SingleStore webinar, heads up that we have weekly technical workshops demoing data and AI use cases and new technologies. In fact, next time we'll be presenting how to build a financial analytics app using OpenAI and LangChain. During that time, lead cloud solution engineer Dave Lee will be presenting his demo on how to build a speech-to-query ChatGPT financial app. It's very cool. You can talk to it about the stock market and etc. If the topic sounds fun to you, feel free to register right now. I'm gonna paste the link here in the chat once I complete this introduction. Back to today's topic, we have a fantastical team of experts also joining us here in Zoom. We have Akmal and Eric. They're going to answer any of your questions throughout the session, so feel free to use the Q&A function in your Zoom console. I'll also flag some questions throughout the presentation that we can have the team here, Madhukar and Alex, to answer them at the end of the presentation. If anyone wants to try our product today, you'll get the chance to enter a raffle to earn one of our new branded AirPods Pro. I'll also paste here in the chat the link, but you can use your cell phone to take a snapshot of the QR code here and head to our cloud trial platform. We'll announce the winner by the end of today's session. And after today's webinar, everyone here that is joining us will receive an email with the recording, with the GitHub repository, the video to watch later, and the materials that are going to be used. So let me introduce to our speakers today. We have Madhukar Kumar. He's our Chief Developer Evangelist here at SingleStore. He originally came with a background in software engineer and is most recently has led product marketing and product management teams in the cloud data industry. And we also have Alex Pang. He's our growth engineer here at SingleStore. With all of that, I'll pass it over to you, Madhukar. Welcome to both of you. Madhukar, you now have the floor.
Thank you, Diogo. And good morning, good afternoon, good evening, wherever you are. This is truly becoming very exciting because of the sheer amount of new changes that keeps happening in generative AI over week. And of course, a couple of weeks ago, we saw that Meta or Facebook, they introduced Llama 2 as an open source LLM. And if you've been part of our webinars, you would see that we talk a lot about how companies are trying to build out LLM apps, which is very private to their own data, and it is specific and customized to what they do. So I think with the new things that is happening, and specifically with Llama 2, this is like a really good entry point where you can now have your entire stack being running either on your local computer if you want to run it, and if you have powerful computers, which is what we're going to show today, by the way, with Alex's, what he has built out, or you can do this in your private VPC. It could be in Google, it could be in AWS, or it could be in your choice of data center that you're running with. So today, what we want to talk about is first take a step back and say, why even build a private GenAI app? And if you think about where the LLMs have evolved, it's typically more on two different broad categories. One is the B2C, and the other one is the B2B. The B2C ones is, of course, ChatGPT. So it's a chatbot. You can ask it to do certain things, and it can give you recommendations, but it can also do other things as well, like it can interpret your code and so on and so forth. But it's typically aimed at a single user. And on the other side, if you look at what where the rest of the world is evolving, so on the B2C side, there's ChatGPT, there is Perplexity AI, there is Bing, and then there is there are a few others that are all chatbots. Some are connected to the internet, so you can directly ask questions of things that have happened recently, whereas ChatGPT, its knowledge is up to September of 2021. But on the other side, we see a bunch of commercial LLMs that have been released. And these could be Cohere, there is Anthropic's Claude 2, and of course, there is open source. Now, when it comes to open source, Hugging Face is one place where you get a lot of open source LLMs. And I'll tell you a little bit of a story of how Llama 2 came about. But where the world is headed, at least in my opinion, is a lot of companies are looking to not only have their ensemble LLMs, because certain LLM models are better at some things versus the other. And you might want to try out both open source as well as commercial ones, but you have to have a tech stack or an architecture that accommodates for that. And two, most of these LLMs, they don't really know your data or the company data. So that company data could be SQL, it could be JSON, it could be a whole bunch of different structured and unstructured data, and you need to bring that in. And typically, in order to curate that and send that context into LLM in real time, you might most likely end up using something called vectors as well, which we're going to talk about. So primarily, when you bring in your own LLM, there are three things you could do. You could retrain it, which is extremely expensive and not really viable for majority of the companies. You can fine tune it, and there are other fine tuning tools, and we'll do one webinar specifically for fine tuning your LLMs. And the third one is retrieval augmented generation, which is what we're going to talk about. But one other thing you want to have a private GenAI app is your data about your customers or your enterprises or your own company data is private to you. There are data access rules, and you want to be able to have LLM that only talks through that versus, goes over the internet to the B2C version and then be able to broadcast that data or store that data in servers, which may not be an option for the companies. So to begin with, what I wanted to talk about was where is the architecture headed? And in many different ways, it feels like this architecture that we are seeing now for B2B is actually very similar to how even humans think today. You have the memory and context, that's your data, and that data are transactional data, which over a period of time with a lot of analysis and opinion and how you experience it turns into your identity in several different ways. And then there's your PFC, your prefrontal cortex, which makes the decision. This is where the LLMs are, but when you do certain things or you think about, okay, I'm going to go grab a glass of water, you don't think of it in words, you just go and do it. And then finally, when you do it, it is through your receptors and effectors. These are your eyes, your mouth, your ears, and then your hands and fingers as well. So if you break it down into an architecture that is evolving into B2B version of what GenAI applications look, of course, at the top is conversational UI. This is all the interfaces. There's browser plugins that you can build. There is a bunch of UI SDKs, similar to like Vercel and so on. And then, of course, there's audio video interfaces that's also coming about. And this could be either stuff that you build, but very soon, I believe that LLMs will provide you access with generating output in audio and video as well. The second stack, if you still call it prefrontal cortex, then is about LLM ops. This is where you have the ensemble of your LLMs and could be a combination of a bunch of different LLMs. It could be both open source as well as commercial. And then you have agents. These are the programs, the services that goes and does things after talking to your LLM. And then there's also connectors. The connectors are connection points with other applications. So like, for example, if you generated let's say a blog and you wanted to publish it, then it's the agent which will take the connector to maybe a Webflow and then go connect it. And of course, there's an API endpoint on top of that. But all of this is actually founded on the entire data layer of companies. And the data layer of companies, as we all know, comes in both structured and unstructured form. So you might have SQL data, you might have MySQL or Postgres in your structure or in your tech stack. You might have a JSON database or a document database. You also have unstructured data, like a bunch of PDFs sitting around in Google Docs and whatnot. You might have Word documents. You might have Slack conversations that you want to also search and talk with. And you might have customer support tickets. This is very similar to what we built with what's called Squirrel Bot. And it takes all of that data and keeps that data fresh in real time. And then eventually it surfaces it to something called a semantic layer or a contextual database or a contextual data store for the rest of your data. And here, what it does is basically take all of the data in real-time pipeline, and you can do multiple kinds of searches on it. You can do lexical search, which is an exact keyword. You can do semantic search, which is vector-based searches, and you have pipelines to bring in data. And then finally, you're able to run it in a bunch of different environments. It could be in the cloud, it could be hybrid, it could be on-prem as well. And this is an established enterprise-grade database in many ways, because it has DR and so on and so forth. It has data access and RBAC and things like that. And you can also pull in data from, if you have data warehouses like Snowflake or BigQuery, you can pull that data into this layer as well. So what we have seen is SingleStore has evolved into this. And within SingleStore, based on everything that we have been doing for years and years, has made it that layer and how customers have started to use us. And in a way, if I were to describe what SingleStore is today before we get down into the show and tell, it's effectively a database that helps you do transaction analysis and contextualization of your data, which are the three things that's needed for being that semantic layer between your LLMs and the rest of your company data. And if I were to break this down further, basically, you can store data in SQL, which is row-based, and it's a distributed SQL. You can store data in columnar, very similar to what could be Vertica, and it is optimized for analytics. And you also have vectors, so you can store data, or you can store vector data, and then you can run native vector functions like a semantic search, which is dot product or cosine similarity or Euclidean distances. And most importantly, it can process SQL, JSON, and so on. So we have a bunch of different customers, and again, it's not supposed to be a pitch, so I'll speed through it. But a lot of customers have been using us for years and years for real-time analytics that also involved transactions as well. So it's a combination of what we call as transaction analytics and, of course, now contextualization. From a super high-level architecture perspective, any data that comes in, we do a extremely fast commit. So that's in memory and that's in row store. And then as you use the data, the fewer queries that you make for a certain data then goes into the column store and then finally into the object store. The object store, although it seems like it's slower, it is still extremely fast, so roughly about 2 terabytes per second. And that object store could be anywhere in the cloud, specifically S3 in AWS. And then, of course, there are the ways to cluster it. So you have aggregator nodes and leaf nodes structured in a way so you can scale it horizontally. There are 3 things that we did recently, which we're going to talk about, makes it really truly the ideal data store for LLMs. One is we added something called Kai, which adds compatibility for MongoDB API. So if you're using Mongo, you can take all that JSON data, do not change your APIs. And even if you want to use Mongo SH, you can just now immediately start using that data within SingleStore without changing your front-end code. And it's roughly about 800 times faster. And you can do analytics, you can do vectors on top of that. We have had vectors since 2017, and we have customers that have been using production vector data-based applications for years, which has basically, created things like face recognition as well as image matching and so on. And then, of course, finally, the last thing I would say is something called notebooks that we added recently. Think of it as very similar to what you would have. It's Jupyter Notebook, but it sits on top of your database. And it's very similar to what you might be familiar with SageMaker, or you might be familiar with Google Colab, or you might be familiar with other places. What it effectively allows you to do is to run Python code along with SQL on top of the database. So in this example, that you can see, you can import matplotlib, or you can do skykit, and so on, and you can connect to your database, and you can even install LangChain and OpenAI libraries and run your entire applications. So for the last few months, we have been building out these notebooks that get you started. All you have to do is just go get started at SingleStore, take one of the notebooks, change your API tokens, and now you have a fully GenAI app running that you can then go and customize. And so this one is, it's obviously a big deal because we also have IBIS Python library that is now embedded in here. And we also have the dot product, which is the vector function, as part of this as well. So instead of going in and doing multiple different things in order to finally do semantic search, you can do all the semantic plus the metadata matching in one single place. And again, we have plenty of examples that we can give. We talked about how SingleStore has started to be, not started, but for several months now, people use it as the semantic data layer, or just think of it as the contextual data store for talking to your LLM. So what you would effectively do, your GenAI will first ask SingleStore to say, hey, this is what the user asked. Is there anything similar? And at that point, you can do vector, similarity, metadata filtering, and all that, get the data back real time, and then contextualize it to give it to the LLM. Then the LLM takes that data and answers the question to you, which is how you add memory to your LLM, which is long-term as well as short-term. So if you're asking questions related to your specific data, this has become the most standardized way of building applications. This is just an enumeration of what that overall simplistic architecture looks like. And one thing I would add is that at the end of the day, it is about building something that is not just a vector-based search, which is what you would see with a lot of existing libraries. It is a combination of both semantic as well as analytics. So for example, if you were to do a search to say, it's a movies-based app, and instead of just saying that here are the different movies that this user would want based on what they have liked before, what you can do is you can do a search and you can say, show me all users between the age of this and this who logged into my movie app in the last 24 hours and watched a specific movie. And then based on that movie and the category, go do a search and then come back and look at their favorite movies that they've done and give something highly personalized for that user in real time while they're trying to scan for different movies. So that really involves a combination of both deterministic and probabilistic search. It involves doing metadata-based search as well as also looking at similarities and then combining it and returning it in milliseconds. And in this methodology, now you can imagine if you are able to do that on a vast corpus of data for your LLM, you start building out applications that are not only highly customized and private to you, but it can also get closer to what would be called baby AGI or artificial general intelligence, where you are interacting with fast changing data through AI, and that interaction is in a few milliseconds versus few seconds and minutes. So in terms of commercial and open source LLMs, we talked a little bit, but I want to talk a little bit more about open source and Llama. Some few months ago, what happened was Meta or Facebook had released this model called Llama. And it was a limited release to researchers to be able to go and try and test out what an open source model could look like, but they could work on top of it and then change it or fine tune it for specific use cases as well. This limited version of Llama model got leaked along with the parameters and the weights. And when that happened, we got a derivative of that model called Alpaca. And Alpaca was released by Stanford. And what they did was, because it was based on the weights that were available, they made it even better. So Alpaca was a much better version of Llama version. And then eventually there was a website that came about called ShareGPT, which is now, it has taken down, but shared GPT was a place where people were sharing their conversations with GPT. So because this was open source and shared GPT had all that conversational data, which is in effect a way to do reinforcement learning based on human feedback, some people then took Alpaca and fine-tuned it on the conversations that were posted on shared GPT and effectively created Vicuna. And Vicuna turns out was a lot closer in terms of its efficiency as well as the quality to GPT 3.5. And so, there was a lot of controversy around this, that people said you cannot train your open source model against my conversation. So shared GPT eventually took down all those conversations. But this kind of took off its own path, where people then took the Vicuna as well as Llama, created something called Llama CCP, and they were able to run it on a Raspberry Pi. Somebody ran it on a phone as well. They were all experimental, so not that it could work, but it got better and better just because it was open source and the weights were known for it. So more recently, as you would have heard, exactly 2 weeks ago, Meta then released Llama 2. And instead of doing this as a specific limited release, they now voluntarily released this as open source, which is also commercially usable. That means you can take it and you can use it commercially, but to a certain parameter, as long as you have 700 million users per month or something like that. And they released 3 different versions of it. There is the 7 billion parameters, and Alex will talk more about it. There's a 32 billion, I believe, and there is a 70 billion parameter. And a lot of people ask, okay, what does a LLM really look like in terms of a file? Well, it's a binary file. So effectively, you can take this binary file and then put it in your Python or whatever you use for creating your LLM apps or GenAI apps. And then you can do your retrieval augmented generation. So in my own VPC, I download Llama 2. And if I want to, I can fine tune that as well. Again, I said that's a future webinar. And then point it to your SingleStore database, which is your layer or contextual layer to the rest of your data within your enterprise. And now you have an entirely air-gapped application that is running, which is custom to you and is fully private to you. So you can manage the networking, data access, and all of that. And of course, we do a lot of that through SingleStore as well. A couple of things to note, that if you're running Llama 2, typically it is advisable that you run it on NVIDIA GPUs, and you need to have a considerable amount of both GPU memory as well as your RAM. The file size itself, again, Alex will talk a little bit more about it. File size ranges between a few GB to a higher GB, depending on which model you choose. And lastly, you can run Llama 2 or download Llama 2 from a bunch of different places. You can do this on Azure. You can do this directly from Hugging Face, or you can go to this site, which is the Meta Llama 2, and it will give you some URLs once you sign up to go then download it on your own and then utilize it. One thing I will add is that every time you fine tune a model, you have to understand that there will be future iterations of the model. So if you are into fine tuning your model, every time there is a new release of that model, you would have to fine tune that version as well. So it's typically advisable, or at least it's evolving, where instead of fine tuning, what you would do is you would provide context, and that context is the real-time data that is being curated. And the context that you can provide to an LLM depends on which model that you use. For Llama 2, I believe, again, Alex, keep me honest here, is roughly about 8,000 or so tokens that you can send. That's a pretty significant amount. But there are other LLMs that are coming up, specifically around Claude 2 Anthropic, which allows you to give it 100,000 tokens. That means you can literally send it like a fat book anytime somebody asks it, and then use that as a context to return the query from it. So at this point, what I wanted to do was hand it over to Alex, because he did build this entire stack of using Llama 2 along with SingleStore on a local instance. And he will walk through step by step on how to do it. So you can also follow through. A quick reminder, if you do go sign up for SingleStore now, as while we do it, you would also be part of the raffle, as Diego had pointed out earlier, which qualifies you to win an Apple AirPod. So with that, I'm going to stop sharing, Alex, and I'll hand it over to you. And so you can share your screen.
Great, thanks, Madhukar. Hey, everybody. So I'm going to be just walking us through an example of a full stack end-to-end GenAI app using Llama 2. Now, like Madhukar mentioned, Llama 2 is fully accessible and commercially usable, unlike the original iteration of Llama. So if you wanted to download Llama 2, you would actually go, I believe I have the link here in our code README from Hugging Face. You would download one of the Llama 2 models. So in this example, I'm using the Llama 2 7 billion parameter model. That's the smallest Llama 2 model available, but the really cool thing about this model is that you can actually run it entirely locally on pretty accessible hardware. So just to give a frame of reference, I'm going to be running this entire example on my MacBook Air with 16 gigabytes of RAM and an M1 chip. So if that gives everyone a sense of the kind of performance that's needed to get the kind of the most performant version of Llama running on your machine. So just going back to the architecture here, we're going to be using LangChain to form the backbone of this app. To reiterate a few of the pieces that Madhukar was talking about earlier, the backbone of an LLM, the long-term memory of an LLM, is really going to be the vector store. So what does the vector store store? It stores vectors, which are representations of the information that you would like the LLM to have access to. In this case, we're actually going to be tackling a pretty hairy problem. Let's say we were a financial analyst and we were looking at this 177-page PDF of the SEC filing for Manchester United, right? This is a super dense document, probably hundreds of thousands of words. This is a place that an LLM could step in, but it's not as simple as just copy and pasting this entire document into the ChatGPT window. As I'm sure many of you may have tried before, if you try to paste in too many tokens, it'll say that you've reached the token limit. In Llama 2's case, the token limit, I believe, is variable. There's a few fine-tuned versions that can actually go up to 32,000 words. But in general, you'll find that performance of the LLM decreases pretty much exponentially with the number of examples or just the length of the input that you give it. Just like if you were listening to someone talk and they just went on and on and on and on for like 3 hours and they asked you, oh, hey, what did I say at the start of what I was saying? You're probably not going to remember, and the LLM won't either, which is why retrieval augmented generation is so key. Using SingleStore, we can actually we can embed the information that we have into digestible chunks for the LLM, and then retrieve from SingleStore the relevant information using some distance metrics, so like cosine similarity or Euclidean distance. So in this case, we are actually building a fully private version of an LLM. And so this means we're running Llama 2 locally. We can run SingleStore locally. Actually, we can set up a self-managed instance. We're also using a local embedding model, which is, I believe, just embedding model downloaded from Hugging Face. So without further ado, let's just walk through this step by step and go through the code. The first step that you'll want to take when you're building a fully private GenAI enterprise app is you'll want to chunk and embed the data that you are interested in. So this is your proprietary data. This is your customer data. whatever it is, because this is fully private, you have complete control over the data and over how it's accessed and over the security, et cetera, right? So let's go into the code here. In the code, we actually use LangChain to load in the PDF in question, the SEC filing. Then we split it up into chunks, which you can define. But in this case, I think the default is like 1,000 characters or something like that. Once those chunks are split up, you're going to use an embedding model. In this case, we're using all mini LM L6v2 from the Sentence Transformers paper to map the concepts represented in the chunks of text into an information space, so that later on, when you ask a query and you ask a question, you can check which pieces of information are most relevant to the LLM to answering this question. So that brings us to our next step, embedding our user query. So once we have the user query, in this example, we're going to ask, what is the minimum guarantee payable by Adidas, right? We'll embed that in the code.
Alex, sorry to interrupt. Could you just some request if you could just try and maximize the screen a little bit, make it a bit bigger so they can see the code? Brilliant.
Sure,
Thank you very much, sir. Thank you.
Yes. Okay. Yes, it might be a little tiny. Apologies for that. Once you embed your query, then you can run a distance metric or cosine similarity search to find the most relevant documents. Let's actually put this into practice. So before we do anything, we need a vector database to store all of this information that we've now embedded, right? And so in order to do that, we're going to be using SingleStore today. You can go ahead to the website and just click the Start for Free button. You can get $600 of free credits. And once you signed up for SingleStore, you have two options. You can either use our cloud option, or you can actually run your own instance of SingleStore on, say, for example, a Docker container. Once you're inside of SingleStore, we're going to be using a cloud instance today, but you can just as easily go into self-managed licenses and get super easy code that you can just copy and paste into a Docker terminal and spin up your own locally running SingleStore instance. But once you have your first workspace created, you can go ahead and get the connection details for the workspace. If you were working locally, you just use localhost. You can get the relevant like URLs, and you can also set your access details. You can set your username and password. In this case, I've actually already embedded the information inside of the database. So let's take a look. Let's see here. So what this command is going to do is it's going to, I'll just walk us all through it one more time just so we're all clear here. It's going to embed the information in the document. It's going to load it all into SingleStore. It's going to create the relevant tables, the relevant columns for us. And then it's going to take the query that we've also inputted, embed that, and then find the most relevant documents within our vector database for answering this question. Finally, it's going to take all of those relevant documents, collate them together into a prompt for the LLM. And in this case, we're going to be using Llama 2. It's all going to run locally, and Llama 2 will hopefully give us the right answer. So let's see here. Okay, so it takes a minute because all of this is running locally. This isn't going to OpenAI servers or any cloud provider other than SingleStore, though you could just as easily use a private instance of SingleStore. And if all goes well, should get an answer here. So what Llama 2 is doing in the background here is it's crunching through all that information that we provided it. You can see there's the source text provided. There's the page number provided. In this case, we're going to be taking the top 4 most relevant examples. It's going to input it as context into Llama 2, and then Llama 2 is going to give us the answer, 750 million, which I believe is the correct answer. We could even do this live. We could go straight into the document. We could just go to like a random page here. Let's just say we wanted to know, let's say we wanted to know what was, let's say we wanted to know what employee benefit expenses were. But let's say we didn't actually, have that exact term in mind, because if we did, we could just do a simple keyword search. Let's do something a little harder. And this is completely live, so let's see. What were the costs associated with employee benefits in 2022? Let's try another example. Keep in mind, this is the smallest version of Llama. This is the smallest version of Llama, and so the performance of the Llama 2 models actually scales with, strange. It seems it does not want to answer what the costs associated with employee benefits in 2022 were, but that's all right. We have this first example here. Just to go back to what I was saying, the cost, the size of the parameters for each Llama model determines the performance of the actual model itself. So if you were trying to run the largest Llama 2 model available, for example, the 70 billion parameter model, you would need an enterprise grade like GPU. You'd probably need, like, I think the recommended range is like 48 gigabytes of GPU memory. But the 7 billion parameter model very easily run on anything something as simple as like a MacBook Air. Okay, let's go through the rest of these steps here. And then, finally, last step, prompting the LLM with the retrieved information after we've gotten the relevant chunks, as you see in the example here. The source documents, which we pull from our database. That's the full end-to-end example. Happy to field any questions. You can also see, let's see.
Hey, Alex. So there's a lot of questions coming in, and we can answer these some live. But can you go back to that piece of code where we download or use the Llama 2 model specifically?
Sure, yeah. So the Llama 2 model that we're using is from this link, which is in the README of the GitHub repo, where I specifically downloaded just the smallest model. And then just because I wanted to run it locally on my MacBook. Once you've downloaded it, you just move it into the, let's see, you can just move it into the models folder, and that's that .bin file that you download, that 3 gigabyte .bin file that I put in there.
Got it. So just to make sure everybody understood, go to Hugging Face, look for the Llama 2 models. Once you sign in, you download the MyDairy file, and this webinar code that Alex is showing will be available on our GitHub. You download or git clone it and then go into the model, put in the model there, and then, of course, sign up your SingleStore, change your credentials, put in your PDF, and you start using. And Alex, did you put the PDFs in a specific location within the course?
Yes, I totally skipped over that. My bad. I just put the PDF into this data folder, and the way that it's ingested into SingleStore is right here. Here we're using the SingleStore LangChain vector database connector, which allows us to create a vector store in a single line of code, just using this from documents call. We're using the SingleStore LangChain connector. In this case, I've already embedded it, and so I don't actually need to use this from documents call. I just instantiate a new connection with the SingleStore database.
Perfect. All right, let's start. There's lots and lots of questions still coming. So let's go through this one by one. That's the one that's still open. And then both you and I can start to answer. So the first question is from Sanjeev Wadhwa. He says, how do you put NeMo guardrails around this implementation? To that, I would say it totally depends on what you're trying to do, because at the end of the day, it's your code. What we have here is the starter code. So if you are looking at doing things like, checks whether somebody is allowed to access that data or not, you can use RBAC either within SingleStore, or you can apply it at the application layer. The second question is, wouldn't it be a good idea to make you question an input statement so that you could keep asking questions?
I can take that. So that's actually really easily changeable with LangChain. In this case, we're using the retrieval QA chain, which is here. But you could just as easily use I think it's called the conversational retrieval QA chain, which allows you to go back and forth with the LLM in your chat box. So you can ask follow-up questions just like you would with ChatGPT.
Got it. Next question, I'm just trying to read top down as they came in. When you say 7 billion parameter model, what does it mean exactly? This question is from Tom Wang. So when you think about LLMs have two important notions. One is parameter and the other is the weight between the parameters. So an LLM could have a parameter called, let's say, a boy and a king. Those are parameters, just a very trivial example. And if they're closer together, then there is a weight associated with it. So when you say 7 billion parameters, these are 7 billion objects with the weights associated that has been introduced. There are other more weighted or more parameter models as well. So for example, as they say, the 3.5 GPT is 100 billion parameters, and 4.0 is, it's rumored to have several different LLMs with each 100 billion parameters as well. Then there's a question, can we debug the error shown?
So the error shown is likely to do with the actual authentication to the SingleStore database. I took out the password and I think I saved it. But if I put the password back in, it would work. We don't want to leak that over the live stream, I think.
Okay. With Llama and your augmented doc, if the answer is available in both data domains, how does it decide which to use? So the way it works is whatever you provide as the context, that goes into the prompt itself. So it's prompt engineering. So even if it knows the answer with the data it has, it's still going to take into account the context that you have sent, but there's going to be no duplication or no error because the data exists in both the places. What exactly are those parameters? So parameters, again, as I talked about it, you can look it up even in Cohere's documentation. They go into the depths of explaining what that is. But parameters are basically data objects and their relation to other objects. So it could be a word, it could be part of an image, it could be a set of words, it could be sentences, a bunch of different things. Can you talk a bit more about the significance of text splitter and recursive text splitter? Alex?
Yeah, great question. So those are just two different ways that we use, there are two different libraries in LangChain that are used to split up text. I believe, this is just off the top of my head, I think text splitter has a fixed chunk length that it just goes through or iteratively through any piece of text to chunk the information that you're going to embed. And then recursive text splitter, I believe, splits on like new line characters. So like /n. But the bottom line is that those are just different methods of making the information that you would like your LLM to understand digestible. So you use different methods for different data models.
Yeah, and again, there are a bunch of different ways you could engineer this. Like if it's a very, very large document, one methodology is you break it up into chunks, you summarize each chunk, then you combine that summary, then you summarize that, create that into an embedding, and then ask the questions. The other is you just chunk it up and you create embeddings for each chunk. So again, a lot of different customers are trying different things with these. What about MS Excel that is columnar and row oriented with merged headings? What is the best way to dissect it? So typically, if you provide an LLM with a CSV data, which is even separated by commas or some sort of a splitter, it should be able to take that as context and be able to make some meaning out of that. So you don't have to do a lot to curate that data. And in fact, the GPT-4 code interpreter works that way as well. You can upload a CSV and it'll be able to understand that and then be able to respond to it. What if the data requires reasoning across multiple documents that do and don't overlap with each other? Is this type of application more relevant to direct QA use cases? So again, if you think about data in general, when a user is asking something, you are basically curating all the data you have, whether these are multiple PDFs with some overlapping content, or a combination of PDFs, CSVs, or a combination of even JSON data that is coming in. When you curate that data, you're basically providing a prompt to the LLM. To curate the data, you can use, if you're using SingleStore, you can use plain SQL and you can do both mix and match. So you could say, hey, for my structured data, show me something where this column equals this column that, join it with this data where JSON is this and so on. And then finally, you could say, do a dot product of that result with this PDF, and then whatever result you get, take the ranking and re-rank it after you do another search. So because it's all SQL and because it's the fact that you can do mix and match, you can do that in your query. And the neat part is you're using SingleStore, so all of that comes back in a few milliseconds. You then take that data and then send it back to the LLM as context. The next question is, I have a 32 gig V100 GPU. Would it be possible to run the Llama 70 billion on it? To tell you the truth, I have been searching for this as well. I'm not sure. I think the best ones are the gaming desktops that we currently have, which has up to 32 gig of virtual CPU GPUs, but I think this is a pretty good configuration to try and run a 70 billion on it. And if you run it as an experiment, let us know how it goes. The next question is, what is the best practice for content search? Is OpenAI embeddings the best? How to create a conversational system with memory with Llama 2? Okay, that's some very big questions which requires a lot of time, so we can try to answer it and then also cover it up with email. Best practices for content search, I would say it has to be a combination of both keyword match as well as semantic, and try and join your searches with your other content as well. So you want to keep your content almost at the front layer, so to speak, where you have both SQL, NoSQL, JSON, PDF, vector embeddings that you use the most or is the most relevant, and that's what you're searching for in real time. Is OpenAI embedding the best? Again, it's an opinionated answer. I personally think it is, but it also costs money to do this. And every time you convert something, you're paying for it. There are other open source transformers as well. Hugging Face is one of them. And I believe that Llama 2, there is a transformer too. Alex?
Yeah, I can add some color to this too. Choice of embedding model is actually pretty important depending on the data that you are looking to query over. The OpenAI embedding model is, I believe, usually the cheapest to run, though you can get better performance with open source embedding models if you fine tune them. That's probably outside of the scope of this this webinar, but if you fine tune open source embedding models, you can usually get better performance for your own data.
Awesome. The next question is, let's say I deploy Llama 2 on AWS and I host it in SageMaker and use a Lambda function to invoke this endpoint through an API gateway URL. How do I use this model in my Python scripts? The LangChain class called SageMaker API gateway has a lot of issues. Well, again, there are several different ways to use this. I believe SageMaker, as you mentioned, has its own APIs and libraries that you can use to embed your LLM, including Llama 2, or you can just typically, as Alex showed, you can create your entire application within Python, and then within that Python, you call the model either through LangChain or through any other libraries. But this is purely a choice of how you want to use it on your own. Will Llama work for in-context learning type of data? Question and context. Yes, in fact, what we're calling as retrieval augmented generation is in-context learning in several different ways. You can curate the data, send it as context, and then you can also save that answer as well, along with the feedback, which you can then use later on for future conversations. Also considering that you are essentially injecting relevant examples into your prompt directly, how does this trade off with conversation history? In other words, if you were to continue the conversation, would you retrieve the relevant information for each question and forget the old relevant data? Retrieve the relevant information for each question and keep the old relevant, or not retrieve relevant information? How does this trade-off work in terms of how relevant information you give it versus how much it remembers from the conversation? Again, a lot. Yeah, go ahead, Alex.
I can take this. Again, this is pretty implementation and use case dependent. On the point of remembering old data and retrieving fresh data, one approach that's worked well for me in the past that you may want to try is summarizing past responses and then injecting that at the start of the prompt, and then injecting your current context. So the LLM kind of has an idea of what happened before. Though, again, LLMs are inherently limited by their context window size. And that's the whole reason that we're doing this in the first place, this whole retrieval augmented generation pattern. Embedding models can help, though whenever you start a new conversation with an LLM, in some sense, you are always starting fresh. It just depends on how good your retrieval is. And the type of information that you feed it.
Okay. Next question. Is it possible to load directly to SingleStore from memory via PyArrow or a Parquet column-based table? Eric, do you want to take this? Either Eric or Akmal.
Can you repeat it?
Is it possible to load directly to SingleStore from memory via PyArrow or a Parquet column-based table?
PyArrow or a Parquet column-based table. Parquet, yes. Arrow is something we're looking at. We're working on it. But you can get your vectors into the system either just by inserting them with SQL insert statements, or you can use bulk load with the load data command, or you can use SingleStore pipelines. And if you look at our documentation on, just Google for working with vector data in SingleStore, just look at that documentation. It tells how to put the vectors in.
Another question for you, Eric. How much does it take to find the cosine similarity of each document? Did you do something to optimize this step?
Yeah, so cosine similarity is just the same thing as dot product if your vectors are normalized to length 1. And most of these LLMs give you back vectors that are normalized to length 1. So just use cosine similarity. We optimize the performance of cosine similarity via our dot product function by implementing it with single instruction, multiple data instructions. And so, we can do, million on a 16 core machine. We did a search of 16 million vectors in like 5 milliseconds to find, say, the top 5 closest matches. It's extremely fast. And that's a full scan. So that's exact nearest neighbor search. And we're working to increase the performance of SingleStore. I can't tell you everything right now, but look out for announcements during the rest of this year.
Hey, Madhukar, with 2 minutes left, do you want to do one more question maybe before we wrap up?
Yeah, why don't you pick one specific to SingleStore and then you can wrap it up?
Okay, yeah, that sounds good. Let me see, there's a lot of good stuff in here.
Matt, I've got a great one.
Oh, go.
Oh, Diogo's from Brazil.
A lot of questions about that. So yeah, that settles that question.
Okay.
All right.
I think lots of people asking about the slides and the recording. Yes, I mean, you're going to send an email out, aren't you? So the link to the slides and the recording is on GitHub, and that's available now if people want it.
Yes, good call. We'll be sending an email out, and actually I'll put a couple links in here as I wrap things up. So Diogo had to drop. I want to give a quick note before we announce that AirPods winner. As mentioned during the intro, we're going to be doing tomorrow the webinar, How to Build a Financial Analytics App Using OpenAI and LangChain. During that time, our lead cloud solution engineer, David Lee, will be presenting his demo on how to build a speech-to-query ChatGPT financial app. It's very, very cool. If you haven't seen the videos of it online, it's really cool to see him talking to that application. So I'm going to put that link in the chat one more time. Feel free to register right now. And then the final announcement here, today's AirPods winner goes to Ali Shahi, who works at Global Foundries in California. Congrats. Thank you for joining. We'll follow up with you. If that's not you, don't give up, because we're going to announce one more AirPods winner by the end of the day for anyone who tries out this GitHub demo. So check your email in the next hour or so. We'll also put this GitHub link in the chat one more time. Thank you, Madhukar and Alex, for an awesome presentation. Also, thanks to Akmal, Eric, and Diogo for joining the support team here. And thank you to everyone for joining us. Have a great rest of your day. Bye, everyone.
Thank you, everyone.